Did CERN achieve something big, and will it announce it in 2016? I have come across further evidence that CERN has made a significant finding at the end of 2015, specifically in the month of November. During this time, CERN was smashing lead ions at 1,045 trillion electron volts, which was a record, and they noticed changes in energy consistent with the possibility that a new particle was discovered. Some scientists have hypothesized that the particle is a new boson. Others have suggested that the particle is the elusive graviton. A handful are hopeful, but downplaying the findings altogether. Nonetheless, the month of December saw one of the largest submissions of research papers from scientists and theoretical physicists that have ever been recorded. Ever. It was a record month for the submission of papers discussing the new particle at CERN. These papers have been submitted to the online database called ArXiv. The sheer number shows us that something is up at CERN. For a scientist, it is very risky to publish a paper online without that paper being submitted first to a journal for peer review. This exact same situation just occurred with the Nibiru teams who used the ALMA telescope in Chile to spot two undiscovered planetary objects in our solar system. These scientists are putting their reputations on the line by publishing research about CERN's discovery without peer review first. The gamble for these scientists is that if their research is correct, they could strike academic gold by having already uploaded their research to an online database so that everybody can view it. Something is up. Something has been discovered. The discussion is, what is it? There are three major candidates for the particle that was discovered at CERN. The least likely of these candidates is the pentaquark. There are several reasons why the new elementary particle is likely not a pentaquark. First of all, the pentaquark was already discovered and confirmed at CERN in July 2015 after it was accidentally identified during an experiment. If they have previously identified the pentaquark, then it is likely the new particle would have been immediately identified, since they already know the pentaquark's subatomic structure and function and could match this with the new particle. Secondly, the particle of significance has already been identified as an elementary particle. The pentaquark is not an elementary particle by technical definition. It is actually made up of 5 elementary particles. Number 3, it is doubtful the discovery of another pentaquark, which was already discovered in July 2015, would prompt the writing of hundreds of academic research papers and cause CERN scientists to go to social media to express their excitement about what has happened. Fourthly, CERN scientists continue to say that a new boson was identified, not a hadron. Pentaquarks fall into the category of hadrons. The next particle that could have been identified is a new, previously unhypothesized boson. This is the second best explanation for the new particle. First of all, a boson is an actual elementary particle, unlike a pentaquark. If it is a new boson, this would definitely be shocking and change the way we understand the standard model. However, CERN scientists who have observed preliminary data about the particle do not believe it is another type of boson that has been previously unhypothesized. They have suggested that the particle is a graviton. The graviton is the likeliest candidate, and I'm going to tell you why. Its discovery would overhaul the entire system of particle physics, and according to CERN scientist Adam Folkowski, it would usher in a, quote, golden era of particle physics. The graviton is still a hypothetical elementary particle, but is suspected to be larger than the Higgs boson while still being massless. This matches the preliminary descriptions we have heard about the new particle. What's interesting is that from what I have read online about what CERN was doing at the end of November, I actually believe CERN was carrying out experiments specifically hunting for the Graviton. Why, you might ask? Because the Graviton might be the key to the dark universe, to breaking open the door. The Graviton is the only particle hypothesized to leak through time and space and into other dimensions. The Graviton would be a stunning confirmation of what we have been talking about with Isaac Newton in the year 2015. Remember, Newton established early concepts about light being made up of particles. That was a notion during his day that was ridiculous. We now know that Isaac Newton was correct. Light is made up of photons, light particles. It's not clear, however, whether Newton believed that gravity was actually a particle. He did describe it as a force, but we don't know if he described it as a particle. But he might have left a clue. Remember, Newton was very specific about his prediction in the year 2015, relating to the month of September. It was Newton's belief that a temporal gate would open at this time. Newton believed this gate, or door, would arc into a dimension of timelessness. If CERN has identified the Lord particle, the Graviton, the only hypothesized particle that can move through time and space, then Newton's key might have been identified in the year 2015. It would be a stunning confirmation, one that I didn't expect.